Okay, so this is a conversation about preload links. There's also here a link to the actual issue on GitHub for this. It's in the fetch spec, but it doesn't really matter. So this came from an investigation of what preloads are and what they should be. The premise of preload is, I got it from the preload spec. Fetch something early that you're only going to use later, meaning fetch a script now, but don't execute it yet. Execute it only when it's actually needed, or fetch an image now, but don't display it yet. To avoid this situation where too many things that you know you're going to load are delayed, which delays a bunch of stuff you could do in parallel. Really a good thing in general, a good problem to solve. The problem with this premise is that it doesn't go into the detail. It raises a lot of questions. I divided the questions to three topics. One of them is availability of the resource. Like you preloaded it. Is it available forever? Is it available for the next request? Is it available while the preload tag is there? Is it available or not available in workers? Question is not clear, not entirely clear also from the spec, or not at all. Second one is caching. Should, could, would preload interact with the cache headers like vary? What does it actually mean to expire? Let's say you have something that is to expire within a few seconds, and you preloaded it, and then a few seconds passed until it's used. Has it expired? So cache, like, is preload a cache? Should it, like, what does it mean? Is it considered store? Third one, which is a painful one, is error handling. Let's say you preloaded the resource and it's error. Should you try to reload it again once you try to use it? What if it's not an error, but rather it's not like a network error, but rather some resource error, like an image that you can't decode? Should you try to reload it once it's visible? Doesn't it just, even if it's just a 404 unused resource, like, aren't you just creating more network requests by preloading it if that's the case? So those problems I found are not just hypothetical, but actually implemented very differently between the different browsers. For example, resources receiving errors are many times fetched again once they're shown. On Safari and Chrome, invalid preloaded images will be re-downloaded. Using preload with the fetch API, meaning with the fetch function, is totally inconsistent between browsers. Some would do something based on the caching headers of the request, or the force cache mode of the fetch, but it acts very differently. If you go to the issue, which I will share also on the chat, you will see, like, the web platform test I created to check how different preloads act on a different browser, and they just act totally different. Also on Chrome, there is optimization for next request. Means usually when you preload something, Chrome would or Blink would keep it for you for the next request, but not after. After that, it would just, you'll have to rely on it being in the HTTP cache, but the preload might help you or might not. The conclusion I got from it, the main problem is that it doesn't necessarily create a problem for users, because the worst that can happen is that is a new request, like in HTTP cache. But a cross-browser fine-tuning of preloads is difficult. You don't know what to expect. Most likely, if you put some preloads somewhere that's not a trivial use case of something that's not cacheable and you know is going to be loaded soon, there is a very high likelihood that you're going to maybe improve performance on one browser and hinder performance on another one. And in either case, fine-tuning of preloads is difficult. Dan can attest of like when we were working on this together at Wix, how difficult this was. Anyway, you can go to this issue comment to see the test results from a web platform test. Yes. Now, possible solutions, and like before, there might be more. In general, all the solutions try to be explicit about what fetch preload does and try to be simple about it so that users can fine-tune their control and know that the different browsers have a similar meaning to preload, and there are web platform tests that capture that meaning, and they can kind of counter on what it means and have a good strategy around it. So one very naive use of fetch, which is sort of what happens in Chrome in some situations, is that fetch is just loads early and counts on the HTTP cache to keep the response while maintaining CSP and fetch priority and all that stuff. But that's very naive, and one problem with this is that there might be a case, which is not an uncommon case, where you preload something and it just gets kicked away from the HTTP cache by the time it's actually by the time the document actually wants to use it, which I think I wasn't there, but I think was part of why the next level optimization was done. This is a little bit too much on the naive side to be useful. The other way, which is sort of what's happening in Safari and sort of kind of what's happening in Firefox, is that there is a type-specific resource cache, which in the HTML spec is only defined for images, but in the browser implementations is there also for fonts and styles and SVGs, and I'm probably forgetting something. But something like this, that when you preload an image, for example, and it has an as equal image, it's actually a loaded image of the page, and it goes into the list of loaded images. And if if the document wants that image, it can they refer to the same cache. The problem with this that we see on Firefox, we see many on Safari right now, is that again in the situation of errors response errors or invalid images, this will actually create double responses and will make performance worse in the case of missing images. It might be still solvable on a particular level to say that every resource has its own little cache that preload taps into. This would also mean maybe specifying that resource cache, which is currently a browser specific implementation specific data, except for the case of images. And we will need to decide to specify what it means in terms of cache headers, which is currently well specified for images. The other option is to do something that's equivalent to the caches object of service workers, meaning that if you preload something, it ignores the HTTP caching headers, or that it only works if you have HTTP caching headers, but it's generally, I think of it as equivalent of having the link header hold the response that it requests, that it fetches, and later if some element in the document wants to use that URL with the same course origin characteristic, etc., it checks for a list of responses that are captured in current preloads and tries to reuse that response first before calling the fetch algorithm. With this, we need to be careful with workers because they can't have access to the preload list of the document, and we don't want race conditions where this would cause workers to load things twice because they had a race condition with preload, or have the kind of problems we had with import scripts. So this would be similar to having a cache object in a service worker, and if our cache matches the response, we give the response from cache, even if it was an error. Or we don't care if it's an invalid image, we don't care if it's a 404. If we fetched this before, we return it from cache. This is where I got to, and move to the discussion phase.